Good morning, friends. In previous lecture, we have discussed about V belt drives and timing belt drives. Total, I have taken 5 lectures. In that, I covered all the topics in belt drives. In today's lecture, we are going to solve problems on belt drives. You can refer the previous 5 lectures to understand the belt drives concept. Velocity ratio is n2 by n1 is equal to d1 by d2. In some of the textbooks, they have mentioned it as small n2 by small n1, or you can write it as capital N2 by n1. N1 is nothing but speed of driving pulley. N2 is speed of the driven pulley, where d1 is diameter of the driving pulley or driver pulley. Small d2 is diameter of driven pulley. If the thickness of the belt is not considered, at that time you can use this formula. When you're going to consider the thickness of the belt, at that time you need to add thickness to the diameter. It is d1 plus t divided by d2 plus t. Second is power transmitted. P is equal to t1 minus t2 into v divided by 1000, where t1 is nothing but tension in tight side, unit is Newton. T2 is tension in slack side, unit is Newton. And v is the velocity of the belt, and its unit is meters per second. Some of the textbooks, they have written it as v is equal to pi d1 n1 is equal to pi d2 n2. Here I have divided it by 60. If you take pi d1 n1 means the unit will be meter per minute. Here I have divided it by 60. Therefore, the unit is meter per second. The power unit is in kilowatt. For that reason, you need to convert this in meters per second. Next, initial tension in the belt T0 is equal to T1 plus T2 divided by 2. This T1 and T2 is tension in tight side and slack side. Ratio of belt tension, I derived this relationship. From that I have taken this equation, and this mu is nothing but coefficient of friction. Theta is the angle of contact between the belt and the pulley. This is angle of contact. The formula is 180 minus 2 sine inverse r1 plus r2 divided by 2. Here I have multiplied that with pi divided by 180. Okay, the angle, if you don't multiply this with pi by 180, then the angle, sorry, the degree, the theta will be in degree. To convert that into radians, I have multiplied it by pi divided by 180. Okay, this formula is for open belt drive. This negative sign means I have to use this for open belt drive, and for the cross belt drive you have to use positive sign. That is the difference. If the angle of contact is not given, you have to use this formula and find out the contact angle, where C is nothing but the center distance between two pulleys. From that you can note down the value. Actually, this should be r1 plus r2 divided by c. It should be r1 plus r2 divided by c. By mistake I have written it as 2. R1 is radius of larger pulley, R2 is radius of smaller pulley. These are the formulas which will be required to solve the problem. And another two formulas are there. Length of belt for cross belt drive as well as open belt drive, that I have derived directly. I will taking those equations. Okay, let me take first problem. Okay, first problem, in that an engine shaft running at 240 rpm is required to drive a generator by means of a flat belt drive. Okay, first, I will write down the given data. Is mentioned that an engine shaft running at engine shaft means this is driver, engine shaft running at 240 rpm, driver is nothing but n1, n1 speed, driver speed is 240 revolution per minute, is required to drive a generator by means of a flat belt drive. Pulley on an engine shaft has 160 mm. He has given the dimensions of the pulley on engine shaft. It is 160 centimeter dia. Engine shaft means this is a driver. Diameter of the driver shaft is given. D1 is equal to 160 centimeter. Convert it into meter. It will be 1.6 meter. And on the generator shaft, 60 centimeter diameter. Generator shaft is nothing but this is driven. Driven means he has given the diameter of the driven shaft. It is D2. 60 centimeter. Convert that into meter. It will be 0.6 meter. He has asked to determine the speed of the generator. N1 is given. N2 you need to calculate. Determine the speed of the generator shaft in the following cases. He has given three cases. First case is neglecting the thickness of the belt. In the first condition, you have to neglect the thickness of the belt. Second one, when belt thickness is 6 mm. He has given the thickness of the belt. First, you should neglect. Second condition, you have to consider the thickness and find out the N2 value. Third one, consider the thickness of the belt and slip. He has mentioned that there is a 3% slip in the flat belt drive. You have to consider the 3% slip along with the thickness you have to consider. After that, fourth, he has asked to find out the velocity of belt with thickness 6 mm. He has given the thickness, and by using that you need to find out the velocity. Okay, we will take one by one cases. Thickness is given 6 mm, convert that into meter. It will be 6 into 10 raised to minus 3 meter. Slip, it is denoted by capital S, it is 3%. First, I will consider case 1. It is neglecting the thickness of the belt. You need to find out the N2, the speed of driven shaft or pulley. In this, N1 is given, D1, D2 is given, means you have to use velocity ratio formula. N2 by N1 is equal to D1 by D2. Substitute the values of N1, D1, D2. N1 is given as 240 rpm, D1 is 1.6 meter, D2 is 0.6 meter. Substitute that and N2 you will get it as 640 rpm. This is for condition 1. Second condition is given when the belt thickness is 6 mm. Second condition, when belt thickness is 6 mm. Use the velocity ratio formula. You have to add thickness to the diameter. N2 by N1 is equal to D1 plus T divided by D2 plus T. Now, take this term to the right hand side. It will be N1 multiplied by D1 plus D2 divided by D2 plus T. Substitute the value of N1. N1 is given as 240. D1 is 1.6. D2 is 0.6. Substitute the value. Thickness is given as 6 mm. Convert that into meter. It will be 6 into 10 raised to minus 3 meter. Substitute all the values. You are going to get the N2 value. It is 636.04 rpm, revolution per minute. Now use the third condition. In that third condition is given that consider the thickness. Along with that, you have to consider the slip. Slip percentage is 3. From that, you need to find out the N2 value. Use the velocity ratio formula considering the slip. Okay, consider the thickness. Along with that, you have to consider the slip. In my previous lectures, I have given the velocity ratio formula. When slip is there, when you have to consider the thickness at that time, what are the formulas you have to use? I have given that. You just refer that. N2 by N1 is equal to D1 plus T divided by D2 plus T. Multiply that with 100 minus S divided by 100. In this, substitute the values. N2 you need to calculate. N1 is given as 240 d1 is 1.6, thickness is given as 6 into 10 raised to minus 3 meter, d2 is zero point 0.6 plus thickness is 6 into 10 raised to minus 3 meters. Slip percentage is given as 3, substitute the value as 3s value. From that you will get the n2 value, it is 616.9 revolution per minute. This is third condition. Now see the condition 4. In this condition 4, you need to calculate the velocity and he has given the thickness. Okay, we know that a linear velocity of belt at any point remains same. At any point you consider, the velocity will remain same. The formula is v is equal to pi d1 n1 by 60 is equal to pi d2 n2 by 60. Unit is meters per second. In this, he has told that consider the thickness. Okay, when you are going to consider the thickness, you have to add thickness to the diameter. Here I have added thickness to the diameter. In this case, v is equal to pi d1 t into n1 by 60. Substitute the diameter d1 1.6, thickness is 6 into 10 raised to minus 3, n1 is 240, it is given, divided by 60. From that, velocity will get it as 20.18 meters per second. Okay, you have calculated all the values. In the problem, he has asked to find out the n2 using three conditions. You have calculated the value of n2, and at the end he has asked to calculate the velocity of the belt with considering the thickness as 6 mm. You calculate all the values. Thank you for watching the video. In the next lecture I will take the other problems. Thank you for watching.